Hey guys, Gradius here, and this is the video for slope. So, when we're talking about slope is the same exact thing as rate of change. So we talked about rate of change before, and slope is absolutely no different than rate of change. Okay, but the thing with slope is that we refer to it as slope. We refer to rate of change as slope when we're looking at graphs and we're talking about a coordinate plane. Okay, so one thing with slope, you might have heard the word slope used before when people talk about going skiing or snowboarding. They say, oh, I'm going to go to the slope, so I'm going to the ski slope. And that is because when we go skiing or we go snowboarding on the mountain, there's different degrees of slope. So maybe one run will be kind of flat, so you go a little bit slower, and then another ski run will be a little bit steeper, then one will be really steep. And the matter of steepness of each one of these slopes determines how fast you go. And the ski runs are all rated based on the steepness of those runs. They'll be rated by either green circles or blue squares or black diamonds, which all mean whether it's beginner or a little bit more difficult or for experts only. Okay, um, so when we're talking about slope, we're talking about linear equations, linear functions. Okay, so straight lines on a coordinate plane. Okay, and when we're using slope, we're actually trying to figure out how steep is that straight line? What is the rate of change going on there? Okay, so slope is written as a fraction. Okay, with the change in y in my numerator and the change in x in my denominator. We refer to this as rise over run. The reason why, if we're looking at a coordinate plane, so here's my y axis, here's my x-axis. So, sorry guys, it's not working that well. So here's my y-axis, here's my x-axis. The change in y is how much am I changing going up and down, because the change in y is going, my y-axis goes vertical. So that's why it's my rise. So what's the change between, so I'm looking at these 2 points right here. It's saying, well, what's the change vertically here? What's my change, what's my rise? How much is it going up and down? Where the change in x is my run, because it's moving over left to right. It's like we're running on the ground, left to right. Okay, so it's a change in x, meaning from x from here to here, my x's, what am I changing by? Okay, so we're going to look at what I mean by that on the next slide here. So here I have a coordinate plane. I have a straight line on my coordinate plane, okay, and I want to find the slope of this line. Okay, so what I want to do is by finding the slope of the line, I want to figure out, well, what's my rise over run? How much is this changing? Okay, so my rise would be my change in, that's the same thing as my change in y over my change in x. So what we can do is we can look at this line, we can pick out two perfect points on the line. So if I look here, here's a point on this line. It goes right through 0, 0. This I wouldn't use as a perfect point because this right here, it's not going exactly through the point 1, 1. Okay, so it's not going through 1, 1. It's like a halfway point. But this one right here, this is going through the point. Okay, this is going through that point 2, 1. Okay, so I want to figure out what's the change in y and the change in x. What's my rise and my run between these 2 points? And if I keep looking for perfect points on this graph, you'll notice the slope, the change is going to be the same throughout. That's what's nice about these straight lines. So the change in y, the rise over run is going to be the same from this point to this point. It's going to be the same from this point to this point, the same from this point to this point. So when I look at this graph, my rise from this point to this point, it looks like it's only going up 1. So when I'm looking at rise over run, my rise, it looks like it's just going up 1. From this point to this point, the vertical shift between y is from up 1. And then when I'm going over 1, 2. So my run is 2. So the slope for this particular line is just 1/2. And I'm done. That's all I have to do. Okay. Now if we check, is that true for all of these? So this goes up 1 right here over 2. Up 1 over 2. Now if I were to look at it from further points that maybe weren't right next to each other, maybe I want to see it from this point to this point. This one goes up 2, so my rise would be 2, and then my run would be 1, 2, 3, 4. That'd be 2 over 4, which is, if I reduce it, is still 1/2. So it doesn't matter which 2 points you pick. If you were to calculate your rise and your run correctly, you will get the same thing of 1/2. So I can say the rate of change of this particular line, the way it's changing, the slope of this line is 1/2. Okay, let's look at another one. Okay, try to get this one a shot on your own real quick. Okay, and then I'll go over it. So this particular line, now I want to find the slope. So I need to find perfect points. So let's see, I've got a point here. Looks like I got a point here too. Okay, so I'm looking for my rise and I'm looking for my run. So it's rise over run. You have to remember rise over run. That's a big deal. Remember rise over run. Okay, so my rise here, to get from this point to this point, notice I'm going left to right here. To go from this point to this point, I'm actually going down 1. So if I'm going down 1, my rise is actually -1. And then my run, I'm going to the right. That's a positive direction. I'm going right 1. So I'm -1 over 1. If I were to divide that or reduce that, I would just get -1. So the slope of this line is just -1. I'm done. Okay, once we set up the fraction, we reduce it. If it reduces to a whole number, that's fine. That's nothing wrong with that. Or an integer, that's okay. Okay, if I were to check it from 2 different other points, maybe I checked it from here to here. Those are perfect points. I go down 2 over 2. So down 2, my rise is -2. My run is 2. -2 over 2 still reduces to -1. Okay, so that's how we find the slope looking at a graph. Now, one particular thing I want us to look at is the difference between positive and negative slope. Okay, so if we go back to our previous graphs, the first one we looked at was a positive slope of 1/2, okay, because we were going up and over to the right. The second one we looked at is we went down and to the right. So this was a negative slope, okay? If we read these from left to right, if we look at it, we always read from left to right when we read books. So if I were to read my line from left to right, if I just find a point, the point on the line on the left, and I follow it to the right, if it's going up from left to right, it's a positive slope. If it's going down from left to right, it's a negative slope. And that's just important to know the difference between positive and negative. So from left to right, if it's going up, it's positive always. From left to right, if it's going down, it's negative always. And that's just a little trick to help us determining if our slope should be positive or negative. So now I don't have a graph anymore. Now I don't have a coordinate plane. Okay, and we want to find the slope of a line that passes through 2 particular points. So I have the point 3, 4, and I have the point 5, 7. So of course, yeah, I could, if I wanted to, I could graph these 2 points. So I've got 3, 4, 1, 2, 3, 1, 2, 3, 4. And I could graph these points and take a lot of time here. Then I've got 5 and 7, and then I can graph these. Okay, well, a couple things about graphing them is our graphs normally when we hand draw it, this isn't a very good graph, right? So it's not very accurate, and 2, it takes a lot of time. So we can use a shortcut. We can use a formula to calculate our slope. Instead of just counting rise over run, I could use the formula y2 minus y1 over x2 minus x1. Because by doing this, if I calculate those, I'm going to find, here, let's put this graph back up. I'm actually going to find, if I take my y2 minus my y1, that's going to give me my rise. And this is going to, x2 minus x1 is going to give me my run. So we're taking the coordinates and we're just doing a little bit of subtraction to find the difference in my rise by subtracting my y's, and I'm finding the difference in my run by subtracting my x's. So here's what I mean by that. So here's a point and here's a point. So if I want to dedicate this as point number 1, that means this is my x1 and this is my y1. Okay, so because that's point number 1, that means this must be point number 2. And this is then my x2, oops, and my y2. So now what I can do is I can just plug these values into this formula. Okay, so and if we look at it, when I'm counting from here, I've got my y is 7 right here, right, on this particular point, and my y is 4 right here. If I take y2 and plug it into this formula, and y1 and plug it into this formula, I've got 7 minus 4. Okay, and that's going to give me a rise of 3. If I were to count from here, if I'm going from 4 to 3, I'm going up 1, 2, 3. There's my rise. My rise is 3. So it's the same process. Okay. Now, if I look at x2 minus x1, I just plug it in. x2 minus x1. So I've got 5 minus 3. And I'm going to get 2. And that shows me my run of going from here, where I started at 3, going over 1, 2, to 5, all the way over to 5. So there's my run. So my slope of this particular line, that I never even drew, is 3 over 2. Make sure you have this formula down, because you're going to be using this a lot to find your slope real quickly. Okay, so this particular line has a slope of 3 over 2. You do not need to change this to 1 1/2. The reason why is when we end up graphing lines later, we like improper fractions. They're kind of nice for graphing lines. So just leave it as an improper fraction as 3 over 2, and you're good to go. Let's look at another one. So this one, if you want to give it a shot, go ahead and pause the video and try it, okay? And then I'm going to go over it right now. So it doesn't matter what point we choose as point 1 or point 2. It doesn't make a difference. I can make this my second point. Okay, this can be my first point if I wanted it to be. Okay, or this can be my second point. It does not make a difference which one I use it. What matters is that if whatever point I choose to be my first point, I use that as both my x1 and my y1, and those are on the right side of my formula. Okay, so what I'm going to do is because I dedicated this is point 1 and this is point 2, just to show you that it's going to work both ways. Okay, so this is my x1, and here's my y1. That means this is my x2, and then this is my y2. Okay, so make sure that they're paired together, because it matters which order we subtract in. So -2, y2 minus y1 would be -2 minus 7 over x2, -5, minus x1, which is 5. If I work this out, -2 minus 7 is -9. -5 minus 5 is -10. If I have a negative over a negative, that actually makes a positive. So this becomes positive 9/10. Now, what I want to do real quick is just to show you guys of how it doesn't matter which point we use as y2 or y1. Maybe I use this as 1 and 2, just like how maybe we would normally do it. So here's my x1, x2, y1, y2. So y2 minus y1. So if I got 7 minus -2 over x2 minus x1, 5 minus -5. Well, I've got these double negatives here that I got to get rid of, so I got to add the opposite. So this becomes 7 plus 2, which is 9. Oop, that gives me 9. Sorry, guys, I had trouble with the pen. Okay. And then I have 5 minus -5. That also becomes 2 positives. And that would give me a 5 plus 5, which is positive 10. Okay, and I'm done. Okay, so I get the same answer both ways. So it does not matter if you choose which point you designate as your first point and which point you designate as your second point. Okay, so quick recap and we're all done. For slope, we need to use the formula y2 minus y1, which gives us our rise over our run. Okay, so just pick a point and make sure you pair the points together with x2 and y2, x1 and y1, make sure they're paired together. So when we plug them into our formula, they work out. It works out. Okay, so you just plug them in, leave it as a fraction, and reduce if you can. And remember that slope is just rise over run. Okay, so rise over run. So if we're going, the rise is up and down, the run is left and right, and we're just counting that on a graph between 2 perfect points. And that's it, guys. So good luck today, and if you have any questions, let me know.